Last time on Project E.
Because math has to be more complicated, and you know we can't have nice things. Foreshadowing next episode, we're going to talk about
What will we cover next? Stay tuned in to find out.
Hi, I'm Hover Cates, and today we're going to talk about my favorite subject, math, because it's near Christmas. So as you know from last video, last time I talked about how I was going to talk about the unit circle this video. So, of course, I'm going to talk about calculus. I'm just kidding. We're going to talk about the unit circle. Now, there are three things you need to know about a unit circle. They are sine, cosine, and tangent. So, let me show you what those are. Say you got a right triangle with three sides, like this. I just found these random pieces on the ground. And this is the right angle right there. Sine of an angle, this one, would be the opposite side of the hypotenuse. The hypotenuse is the one that's opposite of the right angle. Cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent. It also means tangent is sine over cosine. Now say you have a circle with radius 1 unit, and we like to call this the unit circle because it has a radius of 1 unit. We can see that this triangle makes a certain angle right here. So this is 30 degrees approximately. So the sine of 30 degrees is the opposite over the hypotenuse, which would always 100% of the time be 1/2. Meanwhile, the cosine of this angle would be adjacent over hypotenuse, which would always be the square root of 3/2. We move the angle like this. Now we have an angle of 60 degrees. And the sine of 60 degrees is equal to the cosine of 30 degrees, which is square root of 3/2. And the cosine of 60 degrees is equal to the sine of 30 degrees. You should notice the closer the angle is to this line right here, the lower the sine of that angle will be. So if the angle is like at 90 degrees, the sine will be at its maximum, which is 1. And if it's at 0 degrees, the sine will be at 0. However, if the sine is at 270 degrees, it will be at -1. And so the distance away from this would still be 1, but the sine would be -1. For cosine, it's the same thing, except it's this line down the middle. And cosine has a 90-degree relationship with sine. Now, if that was too complicated or didn't make any sense, I don't blame you, because this explanation is garbage. Why would I ever explain something like this ever again? Basically, the numbers you need to know in the unit circle are 0, 1/2, square root of 2/2, square root of 3/2, and 1. Now, if you think we're done talking about angles, you are certainly wrong, buddy. There are a lot of angle identities I have to talk about. Of course, I already mentioned that tangent equals sine over cosine. However, there's also cosecant, secant, and cotangent. If you don't know what those are, I don't blame you, because you probably won't be using them as much. Basically, secant is 1 over cosine, cosecant is 1 over sine, cotangent is 1 over tangent. Sounds pretty simple. Well, when you get to calculus, it's not going to be as simple. Just a forewarning. Remember when I said sine and cosine have a 90-degree relationship? Well, here's what I'm talking about. Sine squared of x plus cosine squared of x will always equal 1. That's the relationship I'm talking about. Using this, you can find other angle identities which you probably won't use as often. Let's see what we got. 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. See, you probably won't use this as much. Forgot to mention that sine of 45 degrees and cosine of 45 degrees are equivalent at square root of 2/2. What if you have sine of 75 degrees or cosine of 75 degrees? Well, you're not exactly screwed, because there is a strategy you can use to find the answer to that. The strategy is called compound angle identities, and the formula is as follows. For sine, it's the sine of a plus b equals the sine of A times the cosine of B plus the cosine of A times the sine of B. You probably will need a formula sheet to remember this, so be sure to bring one when your next test comes up. If your teacher says you have to remember this formula verbatim, well then they're a bad teacher, and they should feel ashamed of themselves. For cosine of A plus B, it's cosine of A times cosine of B minus sine of A times sine of B. So if you have sine of 75 degrees, as I said, you're not screwed at all. You could just turn that into sine of 30 plus 45 degrees and substitute that in the equation. I almost said plugged in. Never say that in a math class, or else your teacher will be roasting you for the rest of the semester. Or what if you had sine or cosine of 15? Well, there's no two numbers that we know that add up to 15. However, you can subtract using these compound angle identities. See, you can use 45 minus 30. When we're using subtraction, it's sine A minus B equals sine A cosine B minus cosine A sine B. Same with cosine, except the minus turns into a plus. Cosine A cosine B plus sine A sine B. There's also an identity for tangent, A plus or minus B. It equals tangent of A plus or minus the tangent of B, all of that over 1 minus or plus the tangent of A times the tangent of B. It's really confusing. You should probably bring your formula sheet. If your teacher doesn't let you do that, as I said, they should probably let you do that in the future. Now say you have sine of 2 times the number that you know. Well, obviously you can refer to the unit circle, or you could use double angle identities, which have 3 formulas, the second of which has multiple solutions. There's a double angle identity for sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. And they are as follows.
2 sine theta cosine theta, cosine squared theta minus sine squared theta, or 2 cosine squared theta minus 1, or 1 minus 2 sine squared of theta, and for tangent of 2 theta equals 2 tangent of theta over 1 over tangent squared theta.
Now you can tell I'm reading right off the formula sheet I brought here, because you really expect me to remember all of these formulas? Come on. This is exactly why the teacher expects you to bring your formula sheet to the test, because it's absolute torture having to make all the students memorize formulas instead of actually utilizing them. Now let's say you have a triangle, you know 2 of the sides and 1 of the angles, or you know all 3 sides. Well, in that case you could use the cosine rule, which is as follows. I'm going to read this again off of my formula sheet. The side c squared equals the side a squared plus the side b squared minus 2ab times the cosine of c. And the angle C would be the opposite of the side C. This equation can be rearranged to the cosine of angle C is equal to side A squared plus side B squared minus side C squared all over 2AB. This formula applies to all kinds of triangles, including right triangles, non-right triangles, isosceles triangles, whatever. Any triangle out there, this formula works. Now say you know 2 of the angles on the triangle, and only 1 of the sides. Well, of course, you could find the 3rd angle by subtracting 180 minus the other 2 angles. Or you could use the sine rule, which says that side A over the sine of angle A equals side B over the sine of angle B. Again, unlike the unit circle, this is not exclusive to right triangles. This can work for any triangle, just like the cosine rule. Hypothetical situation number, I don't know. There have been so many hypothetical situations in this episode, I've lost count. Say you got 2 sides that you know, an angle that you know. Now what you want to find is the area of the triangle. Now of course it's 1/2 base times height, but that only works for right triangles. However, there is another formula that works for every triangle. Doesn't have to be a right triangle. It is equal to 1/2 times the side A times the side B times the sine of angle C. So now you know the basics of trigonometry, you know how to use the unit circle, hopefully. I did a terrible job teaching that one, admittedly. And you know how to find the area of a triangle without having to use a right triangle. Now there's one more thing I want to teach you about trigonometry, and it's one of my least favorite subjects. Complex numbers. Now the graph of complex numbers is a lot like a regular graph, except the x-axis is the real part of the complex number, and the y-axis is the imaginary part. For example, the complex number 3 plus 4i would be the x-axis 3, and imaginary axis 4. And I don't know why, but I think I'm losing brain cells right now. Okay, so complex number, is represented by the variable z, which is a plus I times b, and that is also equal to a variable r times a cosine of theta plus I times sine of theta, and that is equal to that same variable r times e to the I times theta. And this equation can be rewritten as r times cis theta. Cis stands for cosine I times sine, CIS. Now, some of you may have heard of De Moivre's theorem, and that is incorrect. It is pronounced De Moivre's theorem, and it is r times cis theta, all that to the power of n. That is equal to r to the power of n times cis n theta. Now, right now, you may be saying, Harper, you were just talking about trigonometry, which has a lot of real-life aspects. Why did you have to go and talk about imaginary numbers when they literally have no real-life aspects? Well, you're mostly right. And when I say mostly, I mean there's like one thing that imaginary numbers are good for that I know of. Knowledge of imaginary numbers and how they work can be used to create a perfect fractal, except you can't really create a perfect fractal because we're humans. Fractal is a shape with a closed area and an infinite perimeter. You may ask, how the heck is that possible? Well, I'll show you a picture of a fractal and you'll be like, oh, that kind of makes sense, but still doesn't. This theory was brilliantly explained by Michael Stevens of Vsauce, and I really suggest you should watch some of his episodes. Okay, wow, we have only 4 topics left. Vectors, statistics, probability, and calculus. I don't know which one I should do next. You know what? I'm gonna roll a die to find out. On a side note, my friend said if he rolls 4 6-sided dice, he bets that at least one of them will land on a 6. And I've been thinking, should I take this bet? You know what? We'll find out in the next episode. We're doing probability. Yeah. This has been Harper Cates, and I will see you next time.
Which subject are we gonna teach next? Spin the wheel to find out. Next time on Project E!